So for today's experiment, we're going to be doing a balloon experiment, the waterproof balloon experiment. So I have one balloon here with no water in it, and one balloon here with water. So I've labeled them both. The yellow is no water, and the green is water. So I want to show you guys what happens when you take a heat source or a flame to a balloon with no water in it. It pops! So after this video, I will demonstrate and kind of explain why this happens. So I just want to show you guys a visual experiment right now. So once again, the green balloon has the water in it. And we saw the reaction that happened with the orange balloon or yellow balloon with no water. So let's see what happens with the one with water in it. Oh, look at that. It's not popping. Wow. So as we can see, the water is doing something to the balloon that's not making it pop. Whereas when we did it in the same spot before, the balloon exploded. Now watch what happens when we take the same lighter, the same balloon, and put the flame to the part with no water in it. It explodes. So in the following video, I'm going to explain why. Thank you.
Hi everyone. So I just wanted to talk about the explanation for the balloon experiment that I performed for you guys. To start, I think there's three important definitions that we should consider when looking at this experiment. The first being conduction, which is the heat transfer through solid mediums. Convection, which is a heat transfer through liquid and gaseous mediums. And radiation being the heat transfer without any sort of medium. And the method of heat transfer that I want to focus most on is convection, because that's proven to be the source of heat transfer, or the method of heat transfer within this experiment for both the balloon containing water and the balloon containing solely air. So as you saw, we filled one balloon partially up with air and water, and then one filled solely with air. The one with air, upon being touched by the lighter, popped. The one with the water in it, it was clear that when you held it to the water, it didn't pop, and then when you brought it up to where that air capacity was, it did pop. So what is that? So when the water is in the balloon, it actually absorbs the heat differently and redistributes it. And both heat transfers are a method of convection heat transfer. But the water absorbs the heat that doesn't cause the balloon to pop so quickly and directly. It allows the heat to expand further into the balloon and acts almost like an absorbent for that heat energy. That was lacking in the balloon with no air. The balloon having water didn't burst. It didn't explode. It absorbs it through that rubber coating made from the balloon, and it's carried. The heat's carried away from that one concentrated area, unlike in the balloon with just air in it. So the water, as I mentioned, acts as the vacuum, not a vacuum, but like the sponge for the heat, and kind of equally redistributes it rather than keeping it whole and concentrated on that one location where the source of heat was contacting the balloon. So I hope this was a clear explanation for you guys. I hope you enjoyed my video, and thank you.